Hello viewers, these are key messages from the Ministry of Basic and Secondary Education on the coronavirus. Dear parents, keep children at home at all times. Avoid sending children to shops and markets. Do not engage children in petty trading on the streets and garages. Allow children to play within the confines of the home. Limit visitors into your homes. Adhere to COVID-19 health precautions and guidelines. Schools are closed, but learning continues. Dear teachers, you are encouraged to desist from all forms of group activities involving students. All school premises should remain closed and not to be used for any other purpose. Thank you.
All right, hello viewers. Welcome to yet another mathematics lesson at the senior secondary school level. This lesson, we are going to look at trigonometry. Trigonometry is of different form. You'll see some forms, and here we are going to look at trigonometry 1. Let us see what are we going to get from trigonometry. This is the meaning of trigonometry. Trigonometry means measurements of triangles. In its earliest application, it deals with triangles and the relationship between the lengths and the sides of the triangle. Historically, trig was used for astronomy, geography, but it has been also used for centuries in many other fields. Today, among other fields, it has application in music, financial market analysis, electronic probability, biology, medicine, architecture, economics, engineering, and game development. These are the places where trigonometry is applied in real-life situation. Now, the aspect we will be looking at is the Pythagoras theorem. Pythagoras theorem is related to trigonometry very well because it's from right angle triangle. The Pythagoras theorem is applied. It's applied on a right angle triangle. Now let's see how the Pythagoras theorem works. Many of you already know the formula for the Pythagoras theorem. Now, Pythagoras theorem, let's look at this. We have c square is equals to a square plus b square. C square is equals to a square plus b square. What is this c square plus? C square is equals to a square plus b square. We will find out how it happens. This is only applicable on a right angle triangle. When the triangle is not a right angle triangle, this does not work. The Pythagoras theorem only applicable on a right angle triangle. Now let us look at this diagram here. We have a square here, and if you look at this, you will see how this square is formed. We have right angle triangles, that is what we use to form this square. I will start removing the right angle triangles. You see, they are all right angle triangles, 4 of them. And if you look at it properly, they have their sides A, B, C, and angles inside. The right angle, that is where you have the box. This is indicating this is a right angle triangle, and it also have the same angles. The other sides of the other angles in each of the triangle is P and Q. This triangle, we have the angle P and Q. In this triangle, we have angle P and Q. And these other triangles also, we have the same angle, the same side. This means these four triangles are exactly the same. These four triangles are exactly the same, and we call them congruent triangles. It's called congruent triangle, the same distance, the same angles. They are called congruent triangle. Huh? Now, how do we find the relationship of this triangle to a square so that we'll be able to get our Pythagoras theorem proven? I know most of you already know that Pythagoras theorem, the square of the hypotenuse is equal to the sum of the squares of the other two sides. Now, that is what I want to prove for you here. Using these triangles, and we putting them in the form of a square. All right, this is a square form. Now, in the square, we have this. This is 90 degrees, 90 degrees, 90 degrees. You see the box? It's indicating it's 90. Now, we have another thing inside. You have C, 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 meaning all the sides are equal. We can have a plane shape or a quadrilateral where all sides are equal when it is not a square. But how do we know this inside here is a square? We have to find the angles inside the square. How do we find the angles inside the square? We have P here, we have Q here. The angle, that is this angle that we will have here now, this angle here should be a right angle for it to be a square, the tilt diagram, the tilt shape inside the square. Now, how do we know that it's going to be, how will we find the angle there? First, if I remove this triangle again, if I drag this triangle, the angles in a triangle, if you add them, they sum to 180. That is, if you have P plus Q, that is the triangle, plus 90 is equals to 180 degrees. Angles sum in a triangle. P plus Q plus 90 is 180. If you collect like that by transposing the 90, you have P plus Q is equals to 180 minus 90. So you realize your P plus Q is equals to 90 degrees. P and Q is 90 degrees. If I drag the triangle back to return it to the square, you will be able to know how will you get the other angle. Huh? How will we get this other angle? What we'll do, we add this plus this angle inside plus the angle here. It should give us 180. How will it give us 180? Straight line angle. Straight line angles are 180. And knowing that P plus Q is 90, definitely this one here, this angle here should give you 90. And it is going to be a right angle. If this angle is 90, similarly this will be 90, this one also will be 90, this one will be 90. So you have the square inside. It is not a rhombus, it is a square. Angles in a rhombus are not the same, but in square, all the angles, each angle is 90 degrees. Now, how do we still get the formula? We are still trying to get the formula of the Pythagoras theorem. We have this square here. We will find the area of this square in different ways. To prove the Pythagoras theorem, the hypotenuse square is equal to the sum of the squares of the other two sides. Now, if you look at the square we have here, you were there when I was dragging the object to form the square. You look at this object, if I label them, this side A, or the angle there, sorry, B, this is C, and D. This is a square, because each of the side is A plus B. Now, inside also, we have a tilt shape there, which we prove to be a square. That is A, no, not A, let's call it P now. Inside, here will be P, we have Q. This place here we will have it R, that is this place. Then you have S. You have A, B, C, D as a square. Inside, the tilt squared is going to be P, Q, R, S. That is the tilted square. Then we have other shape. As you can see, the other shapes I told you before is the 4 right angle triangle which we arrange to make the square. You have one of them is APQ, the other one is QDR, the other one is RCS, and the other one is SBP. These are the 4 right angle triangles. Now we will find the area of this square in different ways. How do we find the area of these squares in different ways? First, we know that area of a square, let's say this is our first square. We have A, B, 1 minute. A, B, you have C and D. That is the big square. The length of that is A plus B. The length is A plus B. Here also is A plus B. That is the sides of the big square. How do you find the area of a square? Is side square. So our side here, area of a square is equals to side square. The area there is going to be A plus B whole square. If you simplify this, this will give you A square plus 2AB. If you simplify, you have A square plus 2AB plus B square. So this is the area of the big square. Now this big square, it also is also drawn in another way around. If you go to the, if I get you the next, you can have this inside a tilted square, and that the sides are C, 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 and C. So there you have it as, let me get you back a little. You have them as P, Q, R, and S. So we label that one also. P, Q, R, and S. The area of this square is side square. Area of a square is side square. And our side there is C square. Now we have the tilted square. Let's go back to the diagram again. We have the tilt square. That is this one. Then we have the congruent triangles. How many of them are there? There are 4 of them. This is a triangle, right angle triangle. This is another right angle triangle. This is another right angle triangle. This is also another right angle triangle. Now if you go to find this, if we have the right angle triangle, let's say one of them, we find the area of the right angle triangle. This is B, A, and C. How do you find the area of a right angle triangle? Area of triangle is half base times height. If you look at this triangle, the base of the triangle is A and the height of the triangle is B. So area of a triangle is equals to half B times A. That will give you half AB. This triangle, it is 4 of its kind in that square. 4 of its kind is in the square. So meaning the area of all the triangles will be 4 times half AB. So this you will have 2 goes 1 into 4 is twice. You have 2AB as the area of the 4 triangles in the big square. Now to get the area of the square using the triangles and the tilted square is going to be C square plus 2AB. C square plus 2AB is the area of the tilt square and the 4 triangles together. That is one way of us finding the area of that shape that we have earlier. That is this shape here. The tilt square, its area, plus the area of this 4 triangle is the area of a square. Now, we also found it, area of a square in this way. We just use the big square, that is A plus B, where you have A plus B, that's here. A plus B is the side. You square that, the area of that square is A square plus 2AB. These two areas are equal because it's the same square that we are finding the area. So we equate the two squares, the area of the two squares, that is going to be A plus B square, which is equals to C square plus 2AB. If you expand this, expanding this will give you A plus B, which is equals to C square plus 2AB. After doing the work, if you simplify, you will have A square, that is A times A, plus AB, that is A times B, plus B times A is also AB, plus B square, that is B times B. This is equals to C square plus 2AB. If you collect like terms here, you will have A square plus 2AB plus B square. This is equals to C square plus 2AB. Now look at this properly. You can see like terms in it. Transpose the 2AB to this other side because this 2AB and this 2AB are like terms. So if we have to transpose it, we will have A square plus B square plus 2AB minus 2AB. This is equals to C square. You will see plus 2AB minus 2AB will cancel. That is 0. Plus 2AB minus 2AB is 0. So what do you have? You have A square plus B square is equals to C square. That is the way we prove the Pythagoras theorem. A square plus B square is equals to C square. Look at this properly. This should be applicable on our right angle triangles that we've collected here. Let us take right angle triangle, for instance, the first one, AQP. If you have AQP there as the right angle triangle, this is the right angle triangle. You have A, Q, and P. This is A, and this is B. Here is C. So, applying the Pythagoras theorem, you can see C square here is the hypotenuse, and A square is one leg of the right angle triangle, and another one is B square is the other leg of the right angle triangle. So this is what we will use if we have a problem involving right angle triangle. We can only use this on right angle triangles. The Pythagoras theorem is only applicable on right angle triangles. We have different ways of proving this. This is just one of the ways. So the other ways of proving it, you explore that and find out. Now let's look at questions on Pythagoras theorem. I'll also look at this properly. If you look at this right angle triangle that is rotating here, this is one side square and this is the other side square. Like they fill it with water inside. If they rotate it to the hypotenuse, these two squares will, all the liquid on the two squares will be fitting exactly on the square of the hypotenuse. Now, what is the length of the third side of this triangle? That's a question. What is the length of the third side? The third side what type of triangle is this first? That is what you need to know. Is it a right angle triangle? If it is a right angle triangle, we apply the Pythagoras theorem. So by looking, I know you know it's a right angle, some of you know it's a right angle triangle. And how do you know it's a right angle triangle? It's because the right angle is there. That box is indicating that that triangle, the angle there measures exactly 90 degrees. So we've used the Pythagoras theorem. What is the Pythagoras theorem is c square is equals to a square plus b square. What is c square? Always in the formula, c square is the hypotenuse, the longest side of the right angle triangle. A and B will take the other two sides. But always the c square is the c is the longest side of the right angle triangle. Now we put it in here. This will be our c. Here we'll have our A, and here we'll have our B. So we substitute to find the value of c. So you will have c square is equals to, what is a square? 15 square plus 20 square. So if you solve this, you will have c square is equals to, what is 15 square? 15 square is 225. That is 225 plus 20 square, that is 400. So if you go further, you simplify further, you will have c square is equals to 400 plus 225. That is going to give you 625. To get the value of c, you will have to square root both sides to remove the square. C square is equals to the root of c square. Then you will have also the root of 625. What is the root of c square? Is c. This is equals to the root of 625 is 25. So your third side, therefore, the third side is 25. Therefore, the third side is 25. This is what you do to find the third side of a right angle triangle if the other two sides are given. Let's look at next slide. A similar question. Find the third side of the right angle triangle. Look at this. Always, right angle triangle will have a mark of this. This will be the mark for the right angle triangle. So, the longest side is the hypotenuse, and the other two sides, one of them is A, the other one is B. Irrespective where you put your A and B are, but you just have to know that the longest side is always C. So we will have here as our C, this is A, and here is B. So we apply the formula, that is C square is equals to A square plus B square. C square, C is 15. So we will have 15 square is equals to A square, we don't know A, that is A square, plus B square, that is B is 9, so that's 9 square. So if you calculate this, 15 square is 225. So you'll have 225 is equals to A square plus 9 square, which is 81. You transpose the 81, that is 225 minus 81 is equals to A square. 225 minus 81 is 144. 225 minus 81 is 144. So you will have 144 is equals to A square. You need A, not A square. To get A, you square root both sides. So you will have the square root of 144 equals to the square root of A square. So these squares will the square here and the square root will cancel. So the square root of 144 is 12. So you will have 12 is equals to A. So you are asked to find the third side. The third side now, therefore the third side is 12. So this is the way we find the third side of that right angle triangle. It has a little difference with the first one. What is the difference is there you are finding the hypotenuse. Here the hypotenuse is giving, and you are asked to find one of the other legs of the right angle triangle. All right. We have another question. This one says find the value of x in the diagram below. Find the value of x in the diagram below. Let us look at the diagram. Do we have right angle triangle in the diagram? Yes, by looking you can tell the right angle triangle here. You have two right angle triangles. Altogether you have about 3 triangles, but 2 of them are right angle triangles. We have triangle PQR is a right angle triangle, and triangle SQR is also a right angle triangle. Because of this sign here is telling you this is a right angle triangle. Now, how do we find the value of x in this diagram? First, we have to find this distance here, the distance QR. In triangle SRQ, if I take that triangle out, this is S, this is R, and this is Q. This is the right angle triangle. So this is the right angle rather. Here is 61, this is 11, and this is what is missing. So whenever you have 2 sides of a right angle triangle, you use the Pythagoras theorem to find the third side of the right angle triangle. How do we do that? In that we find the third side. If we are to label them, this will be our A, this is B. I said the longest side is always C. So we applied the formula. The formula is C square is equal to A square plus B square. C square, C square is 61. Huh? C is 61. That is 61 square is equal to A is 11. That is 11 square plus B square. 61 square is 3,721. 61 square is 3,721. This is equals to 11 square. 11 square, if we calculate, we will have it as 121 plus B square. We collect like terms. So we will have 3,721 minus 121, which is going to give us B square. 3,721 minus 121 is equals to B square. If you subtract 3,721 minus 121, that will give you 3,600. 3,600. So this is equals to B square. You are not looking for B square, you want to find B. So to undo the B square, we square root both sides. Huh? So 3,600 is equals to B square. You square root this one and square root here. So the square here will cancel the root. So the square root of 3,600 is going to give you 60, which is equals to B. So the third side of the right angle triangle, that right angle triangle is, the third side of this right angle triangle is given to you as 60. Now how do you find the value of x in that? So when we solve this, we get B. Our B there is 60. After solving, our B is 60. This is now 60. That is the side QR. Now we find X. How do we find X? We use the big right angle triangle, that is triangle PQR. We will find the whole length of PQ, subtract 11 from it, that will give us X. We know that QR, using the Pythagoras theorem, this is going, the whole length here is A, here is C, and here it will be B. B is 60, A is 11 plus X, and C is 65. So we apply the formula. So that one we'll have to use the formula knowing we know two sides completely on the third, on the big right angle triangle, that is triangle PQR. So getting the formula, that is C square is equals to A square plus B square. We get the C, that is the longest side of the right angle triangle. We know C is 65, that is 65 square is equals to A square. A square is where you have A is 11 plus X. So plus B square is what we found before. Our B is 60. So that is going to give you 60 square. If we find the 65 square, we will have 4,225, which is equals to A square plus 60 square is 3,600. Then we transpose it, we will have A square is equals to 4,225 minus 3,600. If we subtract that, we'll have A square is equals to 625. So A square is equals to the root of 625. We root this one also. So the square will cancel the square. A is equals to the root of 625 is 25. That is the value of A. That is the value of A. But we know our A is equals to 11 plus X. A is equals to 11 plus X. A is equals to 11 plus X. A is 25, which is equals to 11 plus X. Now A being 25 substituted, how do we get the value of X? We transpose the 11. So we will have 25 minus 11 is equals to X. Then you will have 25 minus 11. How much is 25 minus 11? 25 minus 11 is 14, which is equals to X. So you are asked to find the value of X in the diagram, and therefore the value of X is equals to 14. So this is what we do to get the value of X. We first find this length, the length QR, that is the smaller right angle triangle. Then after getting that, you can realize we have two sides of the bigger right angle triangle, complete side. Then we use it to find the third side, where a part of it is X, the other part is 11. So subtracting 11 from the whole length of PQ will give you the part that is X. All right. There is another one. what is the value of x in the diagram below? What is the value of x in the diagram below? How many right angle triangles? We have two right angle triangles, and the right angle triangles are BDC is a right angle triangle. The other right angle triangle is ABC. Now we are asked to find the value of x. We first look at one of the right angle triangle where you have two sides. Find the third side of that one, and that third side will help you to find what you are asked to find. So we do that. This is the first right angle triangle. We'll have A here, here will be B, then this will be our C in triangle BCD. So we use the Pythagoras theorem, that is C square is equals to A square plus B square. C square, we don't know C, so we leave it C square, which is equals to A square is 15 square plus 20 square. C square is equals to, what is 15 square? Is 225. 15 square is 225. 15 square is 225 plus 20 square, which will give you 400. Adding C square plus 400, adding the values of C square, that is 225 plus 400, it will give us C square is equals to 625. C square is 625. By forgetting C, we find the square root of 625. 625, and the square root of 625 is 25. So C is equals to 25. But what are we asked to find? We are asked to find x in the diagram. And how do we get x? We have to use the other right angle triangle. Now this other right angle triangle is in triangle ABC. In triangle ABC, it's a right angle triangle, you know. This is a right angle triangle. Huh? So we apply the formula. What is the formula? Because you know it's a right angle triangle, you apply the formula. But here you label here A, this is B. Always, the longest side of the right angle triangle is the hypotenuse, and it is always opposite the 90 degrees. So C also here happens to be the hypotenuse of the triangle, and it is the side that is opposite the 90 degrees. So we use the formula to find it. We got C, we have B, now we look for A, which is equals to X in the other right angle triangle. So we do that. We know the format is C square is equals to B square plus A square. Some of you will say, now he bring B square before A square. That does not change anything, huh? B square plus A square is the same as A square plus B square. So we substitute in the value. We know C is 25. So we will have 25 is equals to B square. What is B? What is B? We look at the diagram. Our B is 24. So B square is going to give you 24 square. 24 square plus A square. So this should be 25 square because it's C square. So 25 square is 625 is equals to 24 square is 576. 576. Then plus A square. We transpose the 576 to the 625. We will have 625 minus 576 is equals to a square. When we subtract 576 from 625, the answer is 49. So we will have 49 is equals to a square. So by square rooting both sides, a is going to be equals to the square root of 49. So a is equals to the root of 49 is 7. A is 7, and the question asks us to find the value of x in the diagram. What is the value of x in the diagram? X, you can see x is equals to a. So therefore, the value of x in the diagram, since a is equals to x, this will be equals to 7. So your x is equals to 7. This is the way we find the value of x in the diagram. Huh? We look at another question. The question says, find the longest side of the triangle ABC below. The longest side. What is the longest side? In the question, the longest side is AC, is the hypotenuse, and that is C when you are referring it to the Pythagoras theorem, because this is a right angle triangle. You can see the mark, and the other two sides are there. How do we have it? We have it in the form of K, 2K centimeter in that form. The longest side is 2K centimeter. How do we do first? We first have to find the value of K. How do we find the value of K? We use the formula for Pythagoras theorem, since the diagram is a right angle triangle. What is the formula for the Pythagoras theorem? Is C square is equals to A square plus B square. C square is 2K. That will give us 2K whole square is equals to A square. We label our A. This is going to be the A, and here will be our B. So 2K square, and this one now A is K plus 1. Huh? So we will have K plus 1 whole square. That is A. What is B? From the diagram, our B is K plus 3. So you will have K plus 3 whole square. Now we will expand these ones that we have here to get the value of K. 2K square is, this square affects the 2 and the K. And the relationship between them is multiplication. So that will give us 4K square. This is equals to, we expand this, K plus 1 times K plus 1, K plus 1 times K plus 1. Then plus, we have another one, we expand this one, K plus 3 times K plus 3. Let me try and get it fit there. So we'll have this as, you have 4K square is equals to, this is going to be K plus 1 and also K plus 1, because K plus 1 square is the same as K plus 1 twice. So then you have plus. You have K plus 3. So we expand this. This is going to give us 2K whole square is going to be 4K square. This is equals to K plus 1. Because it is squared, you multiply it by itself, K plus 1. Then plus, this one is going to give us K plus 3 times k plus 3. We expand them to get the value of k. So you will have here 4k square is equals to k times k, that is k square, plus k times 1, that is k, plus, now we have 1 times k is k, plus 1 times 1 is 1. Then plus, then you have plus k times k is also k square, plus k square plus k times 3 is 3k plus 3k, that is k times 3 times k, then plus 3 times 3 is 9. We collect like terms, we bring the k squares, we put the k's together, and the ones that are without variable, we also put them together. So you will have 4k square, k square, that is 2k square. So if we bring it at the other side, it becomes minus 2k square. Then you have, this is equals to k plus k, that's 2k, plus 3k, that is going to give you 5k, plus another 3k is going to give you 8k. So you will have this as 8k. You have this as 8k. Huh? Then what is left? You will have 1 plus 9. That is the only thing left, and 1 plus 9 is 10. Look at this properly. Do we have to do anything again? Of course, yes. We have 4k square minus 2k square. That is going to give us 2k square. So you have 2k square is equals to 8k plus 10. How does this thing look like? 2k square is equals to 8k plus 10. The variable had a power, the highest power of the variable is 2. So if you have an equation where the highest power of the variable is 2, what type of equation is that? It is a quadratic equation. Huh? So we have to solve it using the quadratic format. To write it in standard form, we will have 2k square minus 8k minus 10 is equals to 0. We use the quadratic format either by factorization or completing the square. We can also reduce the equation because this is 2k square, 8k minus 10. So 2 can reduce everything. Huh? If you reduce, you will have it divide here by 2, divide here by 2, and divide here by 2. You are dividing throughout. So this will give us k square minus 4k minus 5 is equals to 0. If we use the quadratic, solve it by factorization, we look for the two factors in which if we multiply the two numbers, we will have negative 5, and if we add them, we will have negative 4. So these numbers are negative 5 and positive 1. So you will have k square minus 5k plus k minus 5 is equals to 0. We factorize it by grouping. K square minus 5k, we look for the common factor there, and k minus 5, we also look for common factor. So this will be like this. We will have now k outside, that is the common factor. So we'll have k minus 5. Then you have plus. What is the common factor here? There's no common factor, so the common factor is 1. So we have plus 1, then we have k minus 5 is equals to 0. So we get the common factors. K minus 5 is one factor and k plus 1 is another factor. The ones outside, that is k plus 1 and k minus 5 is equals to 0. So the zero property, the zero product property is either k plus 1 is equals to 0 or k minus 5 is equals to 0. K is equals to 1, negative 1, or positive 5. Now, what are we looking for? A distance. So since we are looking for a distance, we cannot get the negative value. So the accurate value is 5. So the k there, therefore our k is equals to 5 because we are looking for a distance. This is about triangle. So what is the unit of the distance? It's centimeter. So we have 5 centimeter as the value of our k. 5 centimeter is the value of k. And what are we asked to find? The longest side of the triangle. What is the longest side? The longest side of the triangle is the hypotenuse. This is the longest side. The longest side, as you can see, is 2k. And when we solve for the value of k, what do we have? 5. So our longest side will be 2 times 5. So our longest side is going to be 2 times 5, which is 10 centimeter. So we are asked to find the longest side. Therefore, the longest side is 10 centimeter.